Okay, in this section we're going to introduce the inverse trig functions. We're going to focus on inverse sine, inverse cosine, inverse tangent. Let's start out with inverse sine. Now the sine function is not one-to-one, so what you need to do first of all, right off the bat, is you need to restrict the sine function. We're going to look at this piece from negative pi over 2 to pi over 2, and technically that's a new function. Let's call that capital sine of x. It goes from the point negative pi over 2, negative 1, to the point pi over 2, comma 1. It's one-to-one, has an inverse. We're going to call that inverse function inverse sine of x. The graph looks kind of like that. It's not a very interesting graph. But anyway, the inverse sine function goes from the point negative 1, negative pi over 2, up to the point 1 comma pi over 2. So what we did was we restricted the sine function, call it capital sine function, to domain negative pi over 2 to pi over 2 and range negative 1 to 1. We found the inverse of that, and that's the inverse sine function. You give the inverse sine function a number between negative 1 to 1, and it gives you an angle. It gives you an angle, but in the fourth or first quadrant. It's actually better to say it's an angle between negative pi over 2 and pi over 2. If it's in the fourth quadrant, it's a negative angle, isn't it? So keep that straight. Well, let's look at some examples then. What's the inverse sine of radical 3 over 2? It's the angle between negative pi over 2 and pi over 2, whose sine is radical 3 over 2. So let's draw a picture of this. The angle, you have to be in the first quadrant if it's positive, right? This would be radical 3 over 2. This would be 1/2. This would be 1. So what angle is that? What angle is that? That's pi over 3, of course. How about this one? Find the inverse sine of negative 1/2. It's the angle between negative pi over 2 and pi over 2, whose sine is negative 1/2. So it looks kind of like this. Sine's negative 1/2, so this would be negative 1/2, 1 radical 3 over 2. What angle is that? Isn't that negative pi over 6? That's right. Let's do some more. Be careful with these. You don't always get the number that you started with. Sometimes you do, sometimes you don't. The best thing to do is just to be careful. Let's work on the inside out. Let's first find the inverse sine of radical 2 over 2. That's the angle between negative pi over 2 and pi over 2, whose sine is radical 2 over 2. So that's pretty easy. This would be radical 2 over 2. This is radical 2 over 2. This is 1. What angle is that? Whose sine is radical 2 over 2. That's pi over 4. So then we just find the sine of pi over 4, and that's radical 2 over 2. In that case, it comes up to be what you started with. But be careful on this next one. Let's first find the sine of 7 pi over 6. Well, of course, 7 pi over 6 is down here somewhere. So the sine, this is negative 1/2, negative radical 3 over 2, and 1. This whole angle here is 7 pi over 6. So the sine would be negative 1/2. So now we want to find the inverse sine of negative 1/2. And remember, that's an angle between negative pi over 2 and pi over 2, whose sine is negative 1/2. So that puts you in the fourth quadrant, doesn't it? This is negative 1/2. This is radical 3 over 2. This is 1. What angle is that negative angle there? That would have to be negative pi over 6, right? So see, you don't always get what you started with, do you? Okay, let's keep on going. All right, let's talk about the graph of the inverse cosine now. The cosine function is not one-to-one either. How should we restrict that? Well, the normal way we usually do it is we look at this piece right here. Oh, let's get the right color here. Look at this piece right here. And so the inverse, first of all, this is the cosine function. We'll call it capital cosine, that red function, where first of all we have to restrict it. It goes from the point 0, 1 to pi negative 1. This is the piece that's one-to-one, so it has an inverse function, right? It has an inverse function, and we're going to call that inverse function the inverse cosine, okay? So what does it look like? Let's see, it goes through here. It's kind of like that, more or less. This would be the point 1, 0. Whoops. This would be the point 1, 0. This would be the point negative 1 pi, something like that. The graphs of these aren't really that important. What's really important is the domain and range. So this is how we do it. We restrict the cosine function to be from 0 to pi. And I'm calling this capital cosine just because it really is a different function. It's not really the cosine function. It's a piece of the cosine function. The range is from negative 1 to 1, so we find the inverse of that. That's called the inverse cosine function. You give the inverse cosine a number between negative 1 to 1, and it gives you an angle. It gives you an angle between 0 and pi. Think of it like an angle in the first or second quadrant, right? Okay, well, let's look at some examples. Okay, remember, the inverse cosine gives you an angle between 0 and pi. So this first one says, find the inverse cosine of 1/2. That's the angle between 0 and pi, whose cosine is 1/2. So that would look kind of like this, wouldn't it? This would be radical 3 over 2. This would be 1/2. This would be 1. So what angle is that? Looks like pi over 3, doesn't it? Find the inverse cosine of negative 1. Remember, that's the angle between 0 and pi, whose cosine is negative 1. Well, look, negative 1, 0. The angle whose cosine is negative 1 is this angle, which would be pi, wouldn't it? Now be careful on these next two. You might not get what you started with. Find the inverse cosine. Find the cosine of the inverse cosine of negative 1/2. So this first one, this is the angle between 0 and pi, right? Whose cosine is negative 1/2. It's going to look kind of like this, I think. Negative 1/2. Radical 3 over 2, 1. What angle is that? That's 2 pi over 3. So we just want to find the cosine of 2 pi over 3. Well, the cosine of 2 pi over 3 is negative 1/2. So there we get the same thing back. Let's look at this last one. We first find the cosine of 4 pi over 3. Let's see, where's 4 pi over 3? Over here someplace? So this angle, 4 pi over 3, is like this. This is negative radical 3 over 2. This is 1. This is negative 1/2. So what's the cosine of that angle? Isn't it negative 1/2? This is inverse cosine of negative 1/2. Well, that'll put you in quadrant 2, though, won't it? So what angle is this in quadrant 2, whose cosine is negative 1/2? That's good old 2 pi over 3. So see, we don't get the same thing that we started with, do we? Always. All right, let's talk about the last inverse trig function. Let's talk about inverse tangent. Well, same story here, third verse. We define the tangent function to be, tangent function, we try to restrict it, right? That's what I should say. The natural way to restrict it is to look at this basically fundamental period right here. And then this piece is 1 to 1. And then what we can do is we can reflect that across y equals x to form the inverse function. Now, it turns out the graph of the inverse tangent is kind of interesting, actually. Let's draw. It's going to have a horizontal asymptote at pi over 2 and negative pi over 2, it turns out, because tangent has a vertical asymptote at negative pi over 2 and pi over 2. So the graph looks kind of like this. Let's see, it looks kind of like this. Notice, for the inverse tangent, the domain of the inverse tangent is all real numbers. And the range, this is the most important part, is negative pi over 2 to pi over 2. See how the range is going to be negative pi over 2 to pi over 2? It always gives you an angle between negative pi over 2 and pi over 2. Furthermore, it's an open interval because you have an asymptote there, so it's not closed interval like sine. Okay, well, let's look at some examples here. So when you want to find the inverse tangent of radical 3, that's the angle between negative pi over 2 and pi over 2 whose tangent is radical 3. Let's see. That would be in the first quadrant, wouldn't it? It'd look kind of like this, I think. This would be radical 3 over 2. This would be 1/2, and this would be 1. Doesn't that angle have tangent radical 3? So that angle is pi over 3. Okay, the second one, find the inverse tangent of 1. Again, remember that? It's the angle between negative pi over 2 and pi over 2 whose tangent is 1. So again, we're in the first quadrant. The angle whose tangent is 1, you can think of this as radical 2 over 2, radical 2 over 2, and 1. What angle is that? That's pi over 4. Okay, let's do a couple more here. Again, with these two, you got to be pretty careful. You might not get what you started with. Just be careful. On this first one, we first are going to find the inverse tangent of negative 1 over radical 3. Remember what that is? That's the angle between negative pi over 2 and pi over 2, whose tangent is negative 1 over radical 3. I think it looks like this. It would be a negative angle, and this would be negative 1/2, and this would be radical 3 over 2. This would be 1. See, if you take the y over the x, you get negative 1 over radical 3. So what angle is that? That's negative pi over 6, so it's the tangent of negative pi over 6. What does that give you? Tangent of negative pi over 6, sure enough, is negative 1 over radical 3. Alright, let's try the last one. You start to see the pattern here. If you take the trig function of the inverse trig function, you'll always get back to what you started. But if you take the inverse trig function of the trig function, you might not. Like this last one. You might not get back with what you started. My advice is just be careful, follow the order of operations. Tangent of negative pi over 4, that would be like this, right? Tangent of negative pi over 4. This would be negative radical 2 over 2. This would be radical 2 over 2. This is 1. So the tangent of that angle is negative 1. This is just the inverse tangent of negative 1. So remember what that is? That's the angle between negative pi over 2 and pi over 2 whose tangent is negative 1. Well, that's negative pi over 4. You get negative pi over 4. So in this case, you do get the same number you started with. Okay, I guess that's it for now. We'll see you next time. Bye-bye.